Friends, this is our next problem. Problem having been chosen or selected from the same book, Modern Physics by Stephen T. Thornton and Andrew Rex. As usual, we first come to its statement. Okay, a particle having a speed of 0.92 c, where c is speed of light, 0.92 c means about 92% of the speed of light. Okay, a particle a particle having a speed of 0.92 c has a momentum of 10 to power minus 16 kilogram. What is its mass? Okay, simple problem. Now we are moving to its solution, but before proceeding to its solution in a formal manner, we first introduce two snapshots. Okay, first snapshot is about Lorentz factor. This snapshot has been taken several times in our previous problems, so we will not discuss it. Okay, second snapshot is about relativistic momentum. This snapshot has also been chosen several times in previous problems. Okay, so we will skip these two snapshots and start our problem formally in a regular manner. Okay, using gamma equal to 1 minus u square over c square. We have used first snapshot which deals with the Lorentz factor. Okay, so we have used this expression, and now we are going to find out the value of Lorentz factor gamma, while we are given in the statement value of u which is 0.92 c, that is to say about 92% of the speed of light. We know that speed of light is 3.0 into 10 to power 8 meter per second. Okay, so gamma becomes equal to this. In place of u, we will place 0.92 c square over c square. Okay, here c square will be cancelled out with c square, and in the next step we will put the value of square of 0.92. Okay, square of 0.92 is 0.8464. Okay, so our expression has been reduced to gamma equal to 1 over under root 1 minus 0.8464, and this alternatively becomes equal to 1 over 0.1536. Okay, what we have done, we have subtracted 0.8464 from 1, and hence our denominator has been reduced to 0.1536 under root. In the next step, we have taken the value of under root 0.1536. Okay, this value is equal to 0.39. Okay, so because 0.39 is in the denominator, so in the next step we will calculate the value of 1 over 0.39, and this value becomes equal to 2.56. Okay, hence Lorentz factor gamma has become equal to 2.56. We know that gamma is only a numerical value, it has no units. Okay, now dear students, in the starting of this problem we had introduced two snapshots. Okay, one snapshot was regarding Lorentz factor, and other snapshot was about calculation of relativistic momentum. Okay, dear students, actually Newtonian momentum or classical momentum differs from relativistic momentum only in the sense that in relativistic momentum the term Lorentz factor is involved as a multiplying factor. Okay, Newtonian momentum or classical momentum is simply equal to P equal to mu. Okay, in classical or Newtonian momentum, Lorentz factor gamma has nothing to do. Okay, this is only in relativistic momentum when we multiply the formula of Newtonian momentum or classical momentum with Lorentz factor gamma. Okay, so relativistic momentum P is equal to mu over 1 minus u square over c square. Okay, actually students, P is a vector quantity, that is why it is written in bold form. Similarly, u is a vector quantity, that is why it is written as in bold form, while u square has been written in simple, because square of anything just becomes a linear value, scalar value. Okay, so in case of square we will not use vector. Okay, anyhow, in this level these minor things are not important. Okay, vector denotation, that is a capital, bold or simple, with arrowhead or not, such things are compulsory in lower classes. Okay, anyhow, momentum P is equal to mu over 1 minus u square over c square, and this can be written alternatively as mu gamma. Okay, because we know that gamma is equal to 1 over 1 minus u square over c square. From here we have to find out mass, and hence mass will become equal to momentum P over u into gamma. Okay, we have found gamma in previous step, which is equal to 2.56. Okay, 2.56. Mass is equal to momentum over u into Lorentz factor gamma. Momentum is given in the statement, which is 10 to power minus 16 kilogram meter per second. Okay, in the statement it is given that momentum is 10 raised to the power minus 16 kilogram meter per second. Okay, so momentum is given as 10 raised to the power minus 16 kilogram meter per second, and u is given as 0.92 c, that is to say about 92% of the speed of light, and gamma, which is just a numerical value without any units, we have calculated it in previous step, which was 2.56. hence we have just put these values in this equation or expression. Okay, so m becomes equal to this over this over this over this. Okay, what we have done actually, dear students, here we have put the value of c. Okay, in previous step 0.92 c was written, but here we have eliminated c and replaced c by its alternate value, which is 2.998 into 10 raised to the power 8 meter per second. Okay, in the next step we will simplify these values. However, it is quite clear that in addition to simplification, meter over second in the numerator will be cancelled out with meter over second in the denominator, and our unit will become only in kilogram. Okay, so our mass is becoming equal to 10 raised to the power minus 24 kilogram over 7.06. Actually, dear students, when we will multiply 0.92 with 2.56 and then we will multiply it by 2.998, then it will become 7.06. Moreover, 10 raised to the power 8, which is in the denominator, will be shifted to a numerator with reverse sign. Okay, in the numerator it will become as 10 raised to the power minus 8. Okay, and hence 10 raised to the power minus 16 and 10 raised to the power minus 8 will be added. So 10 raised to the power minus 24 will appear in the numerator, and hence this becomes equal to 0.142 into 10 raised to the power minus 24 kilogram This figure is to this extent our answer is quite okay, 100% okay, but actually it is not appearing beautiful. Okay, just in order to what we should say, refine it. We have changed its shape from 0.142 to 1.42. Okay, and in doing so our power of 10 will be increased by 1. Okay, it will become 10 raised to the power minus 25 because decimal is being shifted one step ahead. Okay, so our mass has become equal to 1.42 into 10 to power minus into 10 raised to the power minus 25 kilogram. And this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.